Hello and welcome to this tutorial on how to develop in Rust a program that opens a TCP connection to a remote host and performs an HTTP request by hand. Alright, so first of all, let's create our new Rust project. Okay, let's change directory into the project. And let's open this code with our editor. Okay, so this is our project. As you can see, there's the usual structure for a Rust project. This time we won't be adding any dependency to our cargo.toml file because we're gonna use only code from the standard library from the Rust 2018 edition. Okay, let's start with a bit of a context and an overview of what we're trying to achieve. So regarding the context, we know there's the OSI model made of 7 layers, and we know that we're actually in practice using the TCP IP model. So the TCP IP model stands on the OSI transport layer 4 and the OSI session layer 5. This is about specifying an IP address or a domain and a TCP port, for example port 80 for HTTP and stuff like that. This is basically in between the hardware and the routers, modems, network interfaces and stuff like that, and the application layer, the stuff that us developers are used to, like HTTP, FTP, SSH, email stuff, queues like MQTT, AMQP, and stuff like that. If you're interested, I advise you to read about it at this link, or there's even the RFC documentation, and this is, for your information, also related to MIME and MIME types, stuff like that. All right, so let's talk about now the objective for today, and let's summarize what we're going to develop. Okay, so what we want to do is to reproduce by hand what this command is doing. So as we've seen here, HTTP is on application layer, OSI layer 7, but what we're dealing with is actually the TCP IP model. So OSI layer 4 and OSI session layer 5. This means we need to basically open a TCP socket stream, prepare an HTTP request by hand, so dealing with transforming a string into bytes, then send these bytes via the TCP stream, then read the TCP stream to parse the HTTP response, and then close the TCP connection to release the socket resource. All right, so let's start by importing some Rust modules from the standard library. There you go. And then let's start by defining some details about the host and the port we're going to connect to. So we need to basically reproduce this URL. So this is the host and this is the port. And this is the HTTP path, so it will become handy once we establish the TCP connection. Okay, so as a first step, let's just create this TCP connection over a socket. And here you can see we are using the TCP stream structure from the standard library, and we are connecting to the host we defined on line 27. And then just to make sure there are no errors, because this connect function is returning the usual Rust result, we just make sure there are no errors, and in case there's an error, we print couldn't connect to the server. Now, just to have a minimum viable example, let's then close the connection, the TCP stream, and try to run this. Right, so here we are shutting down the TCP stream, and because this is again returning a Rust result, we want to make sure there are no errors, so we expect something and we print shutdown call failed in case there's an error. Alright, so this is very basic. We're not actually performing any HTTP stuff in between. We're just opening a TCP stream and then closing this TCP stream. Let's go ahead and run this to see if it works. Let me show the code. Okay, so we are inside the project and we type cargo run. Okay, so we opened the TCP socket stream and then we closed the TCP stream on that socket. All right, let's move on and try to prepare this HTTP request. So this is how the HTTP request looks like. We're basically building a very long string that is rendered as bytes later. So you see here there's the HTTP verb, and compare this to, curl x get, and then the protocol version. Then we have the host, which is the one we defined here, JSON placeholder typecode.com port 80. And then we have this connection close, which is demanded by the HTTP protocol. Okay, so the next thing is sending the bytes over the TCP stream. All right, so here we transform this string type into bytes, and then we write all these bytes into the TCP stream that is connected to the host, to this host on port 80. And we make sure there are no errors, because this is returning a Rust result, by expecting that is going okay, and otherwise printing couldn't write the bytes for the request. The next step is parsing the response coming from the remote host. Basically, we're invoking a REST endpoint into a remote REST API, and we want to see the JSON object that is returned. So in here we define a string that is gonna host all the bytes that come from the TCP stream, And from the TCP string, we are reading into this string all the bytes. This, as usual in Rust, is returning a result, so we expect that there are no errors, and otherwise we print couldn't read the response. All right, and finally, as we've seen before, we shut down the TCP stream, so we release the socket, and we're done with the execution. Okay, so let's go ahead and run this. Okay, so as you see here, this is the HTTP request we wrote into the TCP stream, and you can see that this is the URL path, this is the host, and this is port 80. Just to compare, there you go, this is the equivalent. Well, actually, this is the equivalent. And then we get the HTTP response, which is saying status code 200, okay, is returning lots of headers, and eventually is returning the HTTP response body, which is the expected one. How can we say that? Because let's prove it. We run this same command to invoke the REST endpoint, and we get back the same kind of information. So that's it for today. We've seen how to establish a TCP connection to a remote host. We performed an HTTP request by hand, and then eventually we shut down this TCP connection with the remote host. Happy Rust programming to everyone, and I'll catch you on the next one.